Number 5, we're going to learn about 4 different angle relationships. The first one is going to be vertical angles, which is right here. So vertical angles are going to be angles formed by intersecting lines. And as you can see here, this is a picture of what intersecting lines. I always will say that it makes the X, okay? So whenever you're seeing that X shape, you should think vertical lines. And now before I fill in the blank over here, I want to kind of look at example 1 and do some investigating. So example 1 says to name 2 pairs of vertical angles. So remember, when we name, we're going to say angle something, and it's a pair, so there's going to be 2 of them. So we have 1 pair of angles, and they say name 2 pairs, though, and the second pair. Before we can get down to actually what the vertical angles are, I want to actually do some investigating and look at their measures. So notice in this picture, I see the X that's happening here, right? And I gave you that one angle here was 40 degrees. Okay, that's actually enough information to figure out what the rest of these angles are based on something that we already know. Okay, so in class, I think it was last class, we learned about different types of angles. And what we want to remember is that an angle that forms a line, the measure of this orange angle here is 180 degrees. This is a straight angle. Okay, so what that helps me figure out is that if this part here is 40 degrees, I actually know what the rest of that angle is by doing 180 minus 40. That gives me 140. So that means that this angle right here has to be 140 degrees, right? And then now what we can do is we can repeat that process again. So let me clear this off. I looked at that straight angle here. Let me rewrite in 140. Okay. Let's now look at a different straight angle. I'm going to look at one going this way, right? That's also a line, which means it's also a straight angle. But I'm going to look at the angle going this direction. So part of it is 140 degrees, right? This first part here that we have. And now do I know what the rest of that angle is? Well, again, it makes up a line, so I can do 180 minus 140, and look at that. I'm going to get that that equals 40 degrees again. So this angle down here is 40 degrees. Very interesting. Okay, and then I'm going to repeat that process one more time, but let's look at the other side of this straight angle going from this direction. Okay. That first part of the angle is 40 degrees here, and then what's the second part? Well, if you notice the pattern, we can do 180 minus 40 and get 140 again. Okay. Now looking a little bit closer at my picture, what do you notice about these 2 angles? This angle and this angle, notice they're both 40 degrees, right? And then we have this angle and this angle, they're both 140. Those are your pairs of vertical angles. So I know that this angle up here and this angle down here are going to be congruent, and this angle here and this angle here are going to be congruent. So let's go back up and fill the blank. Vertical angles are angles formed by intersecting lines that are always congruent. And we can also say this, they're always the ones that are across from each other, okay? So if I'm going to actually answer the question now down here, let's name 2 pairs of vertical angles. Well, the first pair of vertical angles, it was the 40, I think that says GOF, right? That angle there, so that was angle GOF. And it's going to be paired with the one that is across from it, which is SOH. Those are across from each other. So that's one pair of vertical angles. The other pair of vertical angles would be the other 2 that are next to each other. So SOG, that's the left side, and the angle that it's across from that would be FOH, this angle over here. Those are across from each other, and they are congruent. So how does that help us for example 2? Well, in example 2, I'm asking you to solve for x. And notice here, I see that x again, right? And so I'm thinking vertical angles. And luckily, I gave us the 2 angles that are across from each other, right? I have expressions for both of those. So what do I know about the angles that are across from each other, I know that they are vertical, and vertical angles are always congruent. So I'm going to put in some tick marks. Those are congruent, and these orange ones here are congruent, but we don't have expressions, so we don't need that, but just for your knowledge and for your notes, those would also be the same. But so once I have tick marks, once they're congruent, I can set up an equation by setting them equal to each other. Okay, at this point we should be all okay with solving. I'm going to subtract 3x from both sides, get 2x minus 20 equals 24, add the 20 to both sides, and I'm going to get 2x equals 44, divide by 2, and x is going to be 22. And there's my answer. Okay? All right, the next two angle relationships that we're going to learn, I'm going to pair together. It's going to be complementary and supplementary angles. They sound the same, but they're different in one way, in that complementary are two angles that are going to add to 90 degrees, and supplementary are going to be two angles that add to 180 degrees. All right, so looking at the picture here, on complementary, notice, how do I know that this is 90 degrees? I have that right angle box, okay? So the two angles that are complementary are angle M and P, that's this red angle here, right? And angle P and L, that's this green angle here, because they're summing to the entire right angle. If I gave us angle measurements, let's say that the green one was, I don't know, 30 degrees, that's enough information to find what our red angle is, right? I can just do 90 minus 30, since I know they're complementary. And 90 minus 30 gets me 60, so that meant the other angle had to be 60 degrees. All right, similarly with supplementary, I have two angles that are adding to 180. Well, another way to say that is the two angles are forming a straight angle, or the two angles form a line. So I have angle DOJ, that's that first angle in green, and JOT, the second angle in orange, they're adding up to this full straight angle, angle DOT. All right? Well, what if I had some expressions in there? So what if I said that the orange angle was 2x and the green angle was 4x? How can I set up an equation to help me figure out what x is and what the angle measurements are? Well, I know that they are supplementary, which means they're adding to 180. So I can say that the 4x, the green angle, plus the orange angle, 2x, those added together equals 180 degrees. Combine like terms, 6x equals 180, divide by 6 on both sides, and I get that x equals 30. So that's my x value, and we can take that x value and plug back in. So I can do 2 times 30, and that will get me 60, and then 4 times 30, and that gets me 120. And what do you notice about 60 plus 120? That is 180, so it works. A quick memory trick to know complementary versus supplementary: if you think of an S that looks like this, and I'm S meaning supplementary, right? And I chop it in half. Let me do that a little bit better. Chop it in half. Notice I get two letters. I get a C going forwards and a C going backwards. And so the way I remember that is like 90 plus 90 equals the full S, the full 180, right? Another way that would be that C comes before S in the alphabet and 90 comes before 180 numerically, all right? So let's look at our last angle relationship now. All right, last but not least, we're going to talk about perpendicular lines. So now if you hopefully remember this from Algebra 1, but if not, we're going to review it now. Perpendicular lines are lines that intersect at a right angle. So that means they're intersecting at 90 degrees, right? And the notation for perpendicular is going to be this upside down T that looks like this. So let's look at an example here on the left. If I'm going to say in this example that CF, that line segment, is going to be perpendicular to AE. That's how I read that. I'll say CF is perpendicular to AB. Okay? And what that means is if I look at CF and I look at AE, they're going to intersect at a 90-degree angle. So I can take this intersection point at F and know that that point there creates a 90-degree angle. And notice AFE is a full line, so I also know that the other side of that intersection is a 90-degree angle. We can also use that to help us solve some problems. So if we look at this example here, it says that I'm given that, notice BA, that ray, is perpendicular to BC, and they're asking me to solve for x, which means I need an equation. But let's always mark the diagram first. How do I mark something that is giving me perpendicular lines? Well, perpendicular lines intersect at a 90-degree angle. So I have a 90-degree angle right here. So now I know the equation I can set up is 7x plus 27. That's going to equal, well, that expression is representing the angle ABC, and we know that angle is 90 degrees. And so solving here, subtract 27 from both sides, and I get 63. So 7x equals 63, divide by 7, and x equals 9. And there is my answer. All right? So now you can head on to practice your homework. See you in class. Bye.